welcome to today's session. Today's session is on surds, okay? And you know the word absurd. I'm sure you have heard of this word absurd, okay? But this topic is not about absurd, it's not about the word absurd. This topic is about surds, okay? So what is a surd? Right? You already know absurd, but what exactly is a surd? So here, this word surd comes from the Latin word surdus, all right? And surdus means death. Very, very, very interesting. Huh? So surd comes from the Latin word surdus, and surdus means death, okay? And so, these are surds. All right, so you have square root 2, you have square root 5, you have square root 11. These are 3 examples of surds, okay? And, surds come from the root word surdus, right, which means death, right? So what are these numbers deaf to? They are deaf to simplification. So you can see that this square root 2 here is the simplest form already. It cannot be simplified further. It's deaf to simplification. All right, this square root 5 is also deaf to simplification. It cannot be simplified any further. You can shout at it, you can scold it, you can do anything to it, but it's deaf, it's resistant to simplification. So this, square root 11 is resistant to simplification. It cannot be simplified any further. So that's really where this surd is coming from. A number that cannot be simplified any further when you try, even when you try hard to simplify. Okay, so let's go on. I've got lots of questions today. I've got 62 slides. So let's go on. All right, again, we'll go from simple questions and then go on to more difficult questions. All right, so here, what you need to know to do surds, very, very simple. Surds is a very, very compact topic. It's very, very compact because all you need to know is in 2 slides. All right, and this is the first thing you need to know. Square root of x times square root of x equals to x. And this one everyone knows. The square root of x times the square root of x must equal to x. The second thing you need to know is the cube root of x times the cube root of x times the cube root of x equals to x. And the third thing you need to know is that the fourth root of x times the fourth root of x times the fourth root of x times the fourth root of x equals to x. All right. And the fourth thing here is very important. That's why it's in red. X plus y times x minus y is x squared minus y squared. All right, these are 4 things that you absolutely must know. All right, remember surds is a very compact topic. There's not much you need to know. All right, and these 4 are critical. Now, on top of that, there's 2 additional formula that's going to be very useful, and we're going to use them almost instantly. The first one is this: the square root of x times y is the square root of x times the square root of y. This is the first thing. This is the first one here. And the second one is the square root of x divided by y equals to square root of x divided by the square root of y. So everything you need to know that you need to know to do all sorts of surds questions is can be summarized into these two slides. This is the first one, all right, and this is the second one. Very simple. So with that, let's get started with the first question. So the first question is, we'll start simply, as in all my sessions, we'll start simply. All right, so simplify square root of 8. And so what you do is just say the square root of 8, break 8 down into 4 times 2, all right? And using this formula that's up here, 4 times 2 equals, square root of 4 times 2 equals to square root of 4 times square root of 2. And square root of 4 really is just 2 times square root of 2. So that's 2 square root 2. That's all you need to do, all right? Square root of 8 has been simplified to 2 square root 2, and you can go no further. All right, so that's the meaning of surd. It's deaf to simplification. You can shout at it, you can ring it, but it will not be simplified further. So here is an example. You've simplified 8 square root of 8, and you've got 2 square root 2, and you can go no further. Right? So simplify square root of 8. The answer is 2 square root 2. Let's go on to another question. Simplify square root of 12. Again, apply the same formula. All right, this one here. All right, right at the top. So you have square root of 4 times 3, break 12 up into 4 times 3, and then break it up into square root 4 times square root 3. Square root 4 is simply 2. So that's 2 times square root 3, and there you have your answer. Very simple again. All right, let's say simplify square root of 20. Again, break it down. 20 is 4 times 5. Break it into 2 different surds. All right, I've broken 20 down now. I've broken it into 2 separate surds. All right, and here square root of 4 is 2, square root of 5 is, that's dead end for you, so that's 2 square root 5. That's it, really simple. Simplify the square root of 128. So 128, if you remember from last week, is 2 to the power of 7. Right, it's one of those things I ask you to just memorize. 64 is 2 to the power of 6, 128 is 2 to the power of 7, and 256 is 2 to the power of 8. Right, 512 is 2 to the power of 9, and 1024 is 2 to the power of 10. All right, so here you've got 128, so that's 2 to the power of 7. And you break this 2 to the power of 7 to 2 to the power of 6 times 2 to the power of 1. This 2 here is 2 to the power of 1. So here, when you have 2 to the power of 6, break it down further. All right, so your mastery of indices is absolutely critical. So your 2 to the power of 6 is simply 2 to the power of 3 times 2 to the power of 3, which means when we square root this, we simply just get 2 to the power of 3 times square root 2. And that's our final answer, 8 square root 2. Where does 8 come from? 8 comes from 2 to the power of 3. 8 comes directly from here. Right? So that's how you do simplification questions. But let's go on. Because most of the time, you need to do this simplification in your head. All right? I'm showing you the steps here, step by step by step. But really, most of the time for simplification, you really, really need to do it in your head. Okay? So, let's go on to still more questions. Let's simplify 500. So 500 is simple. 500 is just 100 times 5. I've broken down the number. The second step is to break this. I've broken 500 into two numbers, 100 times 5. The second step is to break it down into two surds. So square root 5 times square root 5. Square root 100 times square root 5. So square root 100 is simply 10 times square root 5, and you have the answer 10 square root 5. It's that simple. But you get it to a point where you can do all these things mentally. All right, you need to be able to do all these things mentally. So let's do some more. Square root 242, so break the number down into two numbers. It's 121 times 2. So break it down into two surds. You can see that the steps are similar. All right, I hope that you are beginning to see the steps. The steps are exactly the same. All right, so you have a square root of 121 times the square root of 2. After that, square root of 121 is simply 11. All right, and that's 11 times square root 2, and you got your answer. All right, so look at the steps. The steps are exactly the same. All right, and drill up to a certain point where up to the point where you can do everything off the top of your head. Also, simplify a square root of 1,000. 1,000 is simply 100 times 10. So you've broken down into two numbers, 100 times 10. You've got two numbers there, a multiplication of two numbers. Divide it into two surds, square root of 100 times square root of 10. Square root of 100 is simply 10, and your square root 10 remains the same, all right? Okay, and you've got your answer, all right? Okay, simplify 90, square root of 90. Again, 90 equals to 9 times 10. You've got your two numbers. Now you get your two surds. After that, square root of 9 is 3. Square root of 10 remains there. So your answer is 3 square root 10. Right? Get the hang of this. Simplify square root of 800. This looks slightly difficult. All right, so we will try it. So this is 16 times 800 is 16 times 50. 16 times 50. You've broken it down to two numbers, and we can break 50 still. All right, so 50 we break it down to 25 times 2. So 800 is 16 times 50. We've identified 50 as a number that can be broken down further. So that's 25 times 2, and we apply this slightly different formula, right? This slightly different one, and we break it down into three surds. So I'm introducing this. I'm doing this in this particular approach because I want to show you that you can break it down to more numbers than 2. All right, it doesn't have to be always 2. It can be 3, like I've done here. So square root of 16 is 4, square root of 25 is 5, and square root of 2 remains. It's a surd. It's resistant to simplification, right? So 4 times 5 is 20, so that will be 20 times 20 square root 2. Okay, now let's do square root 8. This is square root 800. Let's do it in a slightly different way. You could have done this. All right, you could have broken 800 into 8 times 100, and you could have broken it out into these two numbers like that. 8 times 100 All right. So you remember, one of the first questions, if I'm not wrong, it was the first question. We simplified square root of 8 into 2 square root 2. This was the very first question. And square root 100 became just 10. All right. When you square root 100, you get a 10. So you get the same answer, 20 square root 2. So whether you break it down into 16 times 50 and further to 16 times 25 times 2, or you break it down into 8 times 100, you ultimately get the same answer. Right? You can break it down in numerous ways. Okay, let's do simplify 512. 512 is simply 2 to the power of 9. All right, remember that 2 to the power of 9, and that can be broken down to 2 to the power of 8 times 2 to the power of 1. This 2 here is 2 to the power of 1. So remember the rules of indices, okay? So 2 to the power of 8, you can break it down to 2 to the power of 4 times 2 to the power of 4. And when you square root this, of course, you just get the 2 to the power of 4. All right, times square root 2. And 2 to the power of 4 is 16. So that's 16 square root 2. Very simple. Okay, we are reaching the end of this. I want to give you many of these questions because I want to get you really familiar with this. You really have to get really fluent with this. Okay, so 720, that is 36 times 20. All right, we've broken it up into two numbers, 36 times 20. And then now we break it down into two surds. The square root of 36 times the square root of 20. And the square root of 36, of course, is 6. All right, but here I've decided to break down 20 into 4 times 5. And we can say square root of 36 is 6, square root of 4 is 2, and square root of 5, leave it as it is. It's a dead end there. We cannot simplify that further. So you have a 12 square root 5 as the answer. All right, so this is the simplified form of this. All right, so, very simple questions. We've started out with very simple questions. Let's get on with something slightly more difficult. So let's simplify this. And this is very simple also. What you do is just to break it down, all right? Use this formula, break it down. So you have 5, the square root of 5 over 4. You break it down into two surds. Same. Here you broke it down into two surds, right? 720 is 1. You break it down into 2. All right, this is multiply. Now for division, it's exactly the same. You break it down into two surds. Square root of 5 divided by square root of 4. Same, no difference here, right? And after that, you have square root of 5 divided by 2 here. And this is the simplified form of whatever you started out with. All right, let's do the second one. Square root of 11 divided by 16. Again, break it down. Always break it down into two surds, okay? And square root of 11, that's it, retain that. And square root of 16, you get a 4 out of that. So that's your answer. All right, that's a simplified form of square root 11 over 16. And that's all you have to do for simplification. Now let's look at something slightly different. Now simplify 1 over square root 2. And you will say that, hey, this is already pretty simple. All right, why are we simplifying this? Now we are simplifying this because the surd appears in the denominator. All right, let me give you an example. If you say, okay, divide by 2, it's easy. Divide by 2 means take a knife and chop it into half. All right, divide by 5. Divide by 5 is really easy. Just take a knife and divide something into 5 parts, into 5 equal parts. Divide by 10. That's easy. Divide a pizza into 10 slices. So you divide a pizza into 10 slices. Everyone has the same exact slice, right? But what do you mean when you say divide by square root 2? Right? There's a problem there. It's really difficult to understand. What do you mean when you say divide by square root 2? So for this reason, you will see that every time a surd appears at the bottom in the denominator, we try to bring it up to the top. All right? And so when we say simplify 1 over square root 2, what we are saying is, can we somehow not have the surd at the bottom in the denominator? Can we have it in the numerator? If we have to have a surd, can we have it in the numerator or not? All right? All right, we understand divide by 2, we understand divide by 3, we understand divide by 100, but we don't understand divide by square root 2. What in the world is that? Right? So here, when we say simplify 1 over square root 2, we mean let's you know, manipulate this to such an in such a manner that the denominator is a proper number, right? Not a surd. So here, this is how you do it, right? 1 over square root 2. This is what you started off with, and what you do is you multiply by whatever your denominator is. So here your denominator is square root 2. You multiply by square root 2 over square root 2. You have to multiply by this because when you multiply by square root 2 over square root 2, you are multiplying by 1. And when you multiply anything by 1, you know, you're not changing that thing. All right? It remains the same. All right? So really, you're multiplying by 1 very cleverly here. All right? So when you multiply by square root 2 over square root 2, look what this magical thing happens. You have 1 times square root 2, which is square root 2. And here you have square root 2 times square root 2. All right? Which gives you a 2. And, you know, look at this. You have transformed this, which is horrible because you have a surd in the denominator, into this. All right? The surd is at the top. All right? So you have a square root 2 and you divide by 2. Yeah, that's understandable. That's a lot simpler. All right? Now let's do this one. Second one. Same. You look at the denominator is a square root 2, so multiply by the same thing. Multiply by 1, square root 2 over square root 2. That's multiplying by 1. And once you multiply that, 2 times square root 2 is 2 square root 2. Square root 2 times square root 2 is square root 2 times square root 2. You know, that gives you a 2. All right? So the 2 on the top and the 2 at the bottom, that cancels each other out. And so you end up with just the square root 2 here. Very simple. Very simple. Now let's look at something like that. Now, you'll be tempted, okay, 6 divided by square root 12. Ha! It's easy. Let's multiply by square root 12 over square root 12. Well, you could do that, okay? But let me show you another way, all right? So what I'm going to do is, I'm going to do this. I'm going to say 6 divided by square root 12 equals to 6 divided by 2 square root 3. All right? Remember our earlier slides, we simplified square root 12 and we got 2 square root 3. All right? And this is simply equal to 6 over square root 3 times square root 3 over square root 3. You can ignore the 2 here. No problems, all right? Because why? You are just trying to convert this square root 3. So just multiply by square root 3 over square root 3. And you will see that the 6 here, there's a 6 on the top. And this is 2 times, this square root 3 times square root 3 becomes a 3. So 2 times 3 is a 6. So the 6 at the top cancels out with this 2 times 3 here, leaving you just with the square root 3. Beautiful. Now, the question that you will ask is this: could I have just gone ahead to multiply by square root 12 over square root 12? You could have, right? You could have. But, you know, I always like to simplify, because when you simplify, you work with smaller numbers. And when you work with smaller numbers, the chances of the odds of making a mistake becomes really, really small. And remember, you know, in maths, you don't want a mistake. You don't want a mistake at all. You want the odds to be really low. And, you know, with smaller numbers, it's a lot easier to handle. And that's why I've done this. So I can multiply by square root 3 over square root 3 instead of multiplying directly by square root 12 over square root 12. So here, same thing. Now look at this one here. I've got no choice. Here I have absolutely got no choice. Here I had an opportunity to simplify this before I, you know, kind of made the calculations. Here I have absolutely no choice. So here I have no choice because square root of 15 cannot be simplified any further. So what I've done is I multiplied by square root of 15 over square root of 15. And at the numerator, I've got 5 square root of 15. At the denominator, I've got 15. And simplifying that, 5 and that is 3. This is 5 and then that cancels out to be 3. So that's square root 15 over 3. Very simple. Okay. Now let's look at something like that. Okay. 3 square root 3 over 5. All right. Again, when you see something like that, always divide into the two surds. So square root 3 over square root 5. All right. And I'm trying to I'm trying to convert this to a number, so I multiply by square root 5 over square root 5. So square root 5 times square root 5 is simply 5, and you have square root 3 times square root 5 is square root of 15. 3 times 5 is 15. So that's the simplified form. All right. Now here again, you look at this. I'm again showing you it pays when after I've split it up to square root 3 over square root 8, I proceed to simplify this. I don't, I don't go ahead with square root 8. I simplify it with 2 square root 2. All right? And once I've done that, I multiply by square root 2 over square root 2. All right? Multiply by 1. Okay, so here you have 2 times square root 2 times square root 2. Square root 2 times square root 2 is 2. So 2 times 2 is 4. Square root 3 times square root 2 is square root of 6. So I simplified this to this square root of 3 over 8 to square root of 6 divided by 4. All right, so that's how you do this simplification questions. Let's go on a few more before we go on to more difficult questions. This is 10 divided by square root 20. So again, square root of 20 can be simplified. So simplify it first. All right, don't rush in. All right, just simplify it first. And the simplified form of square root 20 is 2 square root 5. All right, and that's, when you have 2 square root 5, you're trying to convert this to a real number, so you multiply by square root 5 over square root 5. All right, and 2 times this becomes 5, cancels out with a 10, leaving you just with the square root 5. Okay, a beautiful, beautiful answer there. All right, 2 square root 2 over 3. Again, divide it into the 2 surds. All right, and multiply by square root 3 over square root 3. Why square root 3 over square root 3? Because that's the surd in the denominator. All right, and when you do that, you will see that your denominator becomes 3, and your numerator is just a square root of 2 times square root of 3 equals to square root of 6. So that's how you do simplification. Now let's look at other types of simplification questions. You have a square root of 8 minus square root of 2. Very simple. Square root of 8 minus square root of 2. All right, to simplify these things, somehow you've got to change this into a square root of 2. All right, so that's how I do it. Square root of 8 equals to 2 square root 2 minus square root 2. 2 of this minus 1 of this. All right, 2 square root 2's minus 1 square root 2. That's how you read this. So you get just square root 2. Very simple. So this has been simplified to just square root 2. Now let's try to simplify this. Now you say this is an 8 and this is a 32. But you remember 8 is 2 to the power of 3. 32 is 2 to the power of 5. So these things, if you remember them, it's wonderful. All right, so 8 is 4 times 2, 32 is 16 times 2. So that's what you do. All right, so 8 has been converted to 2 square root 2, and 32 is 16 times 2. 16 times 2, when you bring 16 out of the square root sign, it becomes 4 square root 2. All right, so I've converted it, simplified it in my head mentally. I've converted it, and 5 times 2 square root 2 is 10 square root 2 minus 4 square root 2. 10 of these minus 4 of these, you get 6 square root 2. Very simple. Let's go on with this. 3 square root 27 plus square root 12 minus square root 3, I think. All right, okay, minus square root 3. The panel is this, in the way. So here again, convert this mentally, all right? Simplify this mentally. And you'll see that 27 is simply 3 square root 3. 12 is simply 2 square root 3. And of course, you have a remaining minus square root 3 here, which just remains. And once you really need to be able to spot this. 27, what's it? It's 3 to the power of 3. 12 is 3 times 4, and so on. So here, once you're able to do this, 3 times 3 is 9 square root 3, plus 2 square root 3, that's 11 square root 3, minus square root 3 is 10 square root 3. 9 plus 2 is 11, 11 minus 1 is 10 square root 3. All right, so that's how you do this simplification. Now let's go on. You have a 2, you have also got a square root, 2 square root 80 minus 125, a square root of 125 minus a square root of 45. Okay, and you'll be wondering how to do this. Okay, very, very simple. All of them, you can simplify it to something square root 5. All right, so 80 is 16 times 5. What is 80? 80 is 16 times 5. All right, 16, when you bring it out of the square root, it becomes 4. And that's how I got my 4 here. All right, 80 is 16, 16 times 5. So when you bring it out, it becomes a 4. 125 is 25 times 5. And when you bring the 25 out, it becomes a 5. All right, and 45 is 9 times 5. When you bring the 9 out, it becomes a 3. So, you have a 2 here, so settle that. 2 times 4 is 8. So 8 minus 5 is 3. 3 minus 3 is 0. So that's it. Simple. When you simplify it, you get a 0. That's all you get. Okay? Now, simplify this. Okay, simplify this one here. The answer is already out. So here you have, something that can be, the hint is right here. All right, this cannot be simplified any further. So here we must look for something that can be multiplied by 6. And this is 4 times 6. This is 9 times 6. All right, 4 times 6 is a 24. 9 times 6 is a 54. So just write it down and retain the 10 over here. This 54 is 9 times 6. When we bring the 9 out of the square root sign, it becomes a 3. So that's 3 square root 6. This 24 is 4 times 6. So when we bring the 4 out of the square root sign, it becomes a 2. So it's a 2 square root 6. And retain this 3 square root 6. So when you simplify this further, all right, do the spring cleaning, clear up everything. 10 times 3 is 30. 2 times 2 is a 4. And the plus 3 remains. So 30 minus 4 is 26. 26 plus 3 is 29 square root 6. And that should be your answer. Okay, let's go. All right, it looks a bit difficult. It looks a bit tough. All right, and what do we do with this? Right, so it's very simple. Again, square root 27 equals to 3 square root 3. All right, always bring it to the simplest form because, it works. It works. All right, and you deal with smaller numbers. It's always nicer. It's always safer. It's always more convenient to deal with smaller numbers. So square root 27 is 3 square root 3. Square root 12 is 2 square root 3. All right, because this is 9 times 3. When I bring 9 out, it becomes a 3. So 3 square root 3. This is 4 times 3. So when I bring 4 out, it becomes a 2 square root 3. Now I see some, the common one is 6 square root 3. All right, 3 times 2 is a 6. The square root 3 is common. So when I simplify it in this way, you see that the numerator is simply 6 square root 3 divided by 3 square root 3 is 2. Times 1 is a 2. Divided by minus 6 square root 3 divided by 2 square root 3 is 3. Times 1 is 3. So it's 2 minus 3 on the top. So 2 minus 3 is simply a minus 1. Okay? And this is what we simplify. All right, we really don't simplify this. We bring it to this first, all right, and we simplify this. And we simplify by multiplying by square root 3 over square root 3. Remember that, you don't have to have a 6 and 6 here. Just take care of the surd. That's all you need to do. The 6 and 6 does not need to appear, right? So just multiply by 3 square root 3 divided by square root 3. And 1 times, the minus sign goes right there. 1 times square root 3 is a square root 3. 6 times 3 here gives you an 18. So this is the simplified form of this thing here. All right, this expression here. Okay, let's go on. Something, that appears only in the denominator, 1 over 2 square root 3 minus 2. And it's the same. All right, now this is a little bit complicated because you have a 2 square root 3 minus 2. What do you do? All right, what you do is very simple. What you do is, remember, A minus B, A plus B. Remember that. All right, A minus B times A plus B is A squared minus B squared. So that is very, very important. So here you have a 2 square root 3 minus square root 2. What you multiply it with is 2 square root 3 plus square root 2. And of course, on the top, it has to be the same. You have to repeat it at the top because then you are multiplying by 1. All right? So you're not changing the question. So here, remember, 2 square root 3 minus 2, you have to multiply by 2 square root 3 plus 2. The minus, you have to change it to a plus because you have to use the a plus b times a minus b equals to a squared plus b squared. That's what you're using. So what do we have when we do this? What we have is this. Amazing. So a minus b, a plus b. What you get is a squared minus b squared. Let me repeat that because this is very, very, very important. You have an a minus b, you have an a plus b. So what you get is a squared minus b squared. All right, and of course 1 times this is just that. Repeat that because it's just 1 times that. All right, so you know what's so great about this? What's so great is that 2 square root 3 squared is 2 squared is 4. Square root 3 squared is 3, so it's 4 times 3. That gives you 12. And square root 2 squared is 2. So it's just 12 minus 2 in the denominator. You have converted this monster here. This is really scary. All right, you've converted it into 12 minus 2, which is just 10. All right, which is just 10. And the numerator is there. So when you simplify, it's just square root 3 divided by 5 plus square root 2 divided by 10. All right, so this is the you know the technique that you need to learn. How do you you know kind of like convert the denominator? You multiply it by, you know, 2 square root 3 minus square root 2, you multiply by 2 square root 3 plus square root 2. In this way, you are converting it to a number in the denominator. All right, and of course, the rest is just simplification. Now let's go on some more. This looks like a monster. This looks really tough. It looks really, really difficult. But the principle is really the same. No difference, all right? It looks tough, but there's no difference in the answer. So here, this is 2 square root 7 plus 2 square root 2. Now, just change the plus to a minus. That's all you need to do. A plus b, a minus b. All right, this is an a plus b, and this is an a minus b. When you multiply that together, you get an a squared minus b squared. That's the magic of this whole thing. So here, when you multiply this at the bottom, you need to multiply by exactly the same thing at the top, so that you are not changing the question. You're multiplying by exactly 1. So after that, it's just a whole process of multiplying out. That's all. So here you have a plus b, a minus b. This is your a. This is your b, a plus b, a minus b. What you end up with is a squared minus b squared. Here is just 3 times 2 is a 6. Square root 7 times square root 7 is square root 7 squared. So 3 times 2 is a 6 here. The minus sign comes from there. 3 times 2 is a 6. Square root 7, square root 2, just lay it out here. Minus 2 times 2 is minus 4. Square root 7, square root 2 is from here. All right. Now the last one, minus 2 times minus 2 is a plus 4. Minus, minus, plus 4. Square root 2 times square root 2 is here. All right. So once you settle all these things, it looks very messy. It is very messy. All right. It doesn't just look very messy. It is very messy. But just take your time to simplify things. You have 6 times 7 here. This square root 7 squared becomes a 7. This square root 2 squared becomes a 2. So the 7 comes from here, the 2 comes from here. Minus 6 minus 4, you get a minus 10 here. All right. Now the denominator, 2 squared is a 4, and 4 times 7 is a 28. This is a 4 times 2 is an 8 here. So 28 minus 8 is 28 minus 8 is 20. All right, so 6 times 7 is 42. 7 times square root 7 times square root 2 is a square root 14. 4 times 2 is an 8 here. So, you know, it's a process of simplification from here. All right, 42 plus 8 is 50. All right, 50, and that is a 10. Square root 14 divided by 20. And you know, you have 50 here, you have 10 here, you have 20 here. Divide the top and divide the bottom, divide the numerator and divide the denominator by 10. You will get a 5 minus square root 14 divided by 2. How did I get from here to here? Divide the numerator and the denominator by 10. All right, and that's what you have, and that's the simplification. So you have managed to simplify this monster. This is an absolute monster. You have managed to tame this into this particular format. Very, very simple, very tame. Okay, now this is the last simplification one, if I'm not wrong. Okay, and this looks, again, it looks like a monster. You'll be surprised at the simplified results. Okay, it simplifies to something really nice. Okay, so here, you know, 1 over something plus 1 over something else. That's what it is. You have 1 over something plus 1 over something else. What do? You take it to the same denominator. So you multiply this 1 over A plus 1 over B, A times B. That's what's happening here. All right, this raised dot here is the multiplication. All right, and when you put it to the same denominator, on the top here you have square root 3 plus 2 squared, plus the plus comes from here. All right, the plus here comes from there, and that you have square root 3 minus square root 2 squared. All right, so you bring it to the same denominator, okay, and you work from there, right? And you will see that this is a squared times b squared. A squared times b squared is ab squared. This is a squared, this is b squared, so that will be ab squared. All right, now note your indices has to be, you know, really good. All right, because what I'm using here is some rules of indices. Okay, so here a squared times b squared equals to ab squared. That's what it is. Okay, and I'm multiplying this out. The plus comes from there, and I'm multiplying this out. So I've kept this in a bracket to keep things neat, to keep things clear. This is also kept in its own bracket. And when you do that, you will see that, hey, gosh, it's really, really fantastic. Okay, it's really good because why? You have this 3, square root 3 is a minus b, a plus b. So you have square root 3 squared minus square root 2 squared. All right, and when you simplify that, it simply becomes 3 minus 2. So if you look at the next slide, it becomes 3 minus 2. Wonderful. This 2 square root 6 minus 2 square root 6 disappears. Your surd disappears. All right, and your 5 plus 5 becomes a 10. Of course, 3 minus 2 is a 1. 1 squared is a 1, and it's the 10. So here you will see that this horrible thing has been simplified to just a 10. All right, just 10. Okay, now the questions that we have covered so far are simplification questions. Now we're going to go to another set of type of questions in which are solve for x type of questions. Solve for x. And you have this one here. All right, so solve for x, and you have this particular expression here, this particular equation. Now, how do you do that? All right, so you see that it's very complicated because there are 3 square root signs. There's square root of x plus minus 1, square root of x minus 6, and square root of 2x minus 5. Now, you have 3 square root signs there. Now, the secret to these kinds of questions is really easy, is to reduce the number of square root signs one step at a time. So now you have 3 square root signs. Let's see how we can reduce this thing. And what we can do first is just to square both sides. So I'm squaring the left side and squaring the right side. Square up the left side, square up the right side. Now, why am I doing this? I'm doing this so that I can eliminate this square root sign over here. So this 2x minus plus 5 square root, you can see that when I square this, the square root sign just disappears. And that's what I'm trying to do. At every step, understand why you are taking that step. All right, I'm taking this particular step of squaring this so that I can reduce the number of square roots here. There's 3 here, square root of this, square root of that, and square root of something else. There's too many square root signs. So I square that to get rid of that square root sign. All right, so here when I square the left, when I square the right side, I also have to square the left side. So when I do that, I get an x minus 1 from here, x minus 6 from there, and 2 times this times this. So 2 of this and this. And look at the magic that you have done. What happens is this: you have transformed an equation with 3 square root sign to one equation which has just 1 square root sign. this looks like it has two square root signs, but actually it's just one. All right, I'll show you later. So here, simplify this, x plus x is 2x, minus 1 minus 6 is minus 7. X plus x, 2x, minus 1 minus 6, 7. So 2x here, you have 2x, and on the left, 2x on the right, it cancels out. So when you bring the minus 7 over here, you get a plus 7, and you have a 5 plus 7 is 12. So this one remains 2. Now what you do here is just to divide both sides by 2. So you eliminate this 2 by dividing both sides by 2, and what you get is a square root x minus 1, square root x minus 6 equals to 6. Divide throughout by 2. So that 2 disappears, and this 12 divided by 2 is 6. All right? Now, really, this is really square root of x minus 1 times x minus 6. And that's why I said, although it looks like there's two square root signs, there's really just one there. Okay? Now, what you do is, again, you have this here. So what you do is just to square it again. Same thing, square it. And why do you square it? You square both sides so that you can get rid of this and get this. All right? So here you have x minus 1, x minus 6. So you have x minus 1 times x minus 6 over here. 6 squared is just 36. All right? And look at what you have done by squaring it a second time. By squaring it a second time, you have eliminated the square root signs. All right? What you are left with is an equation that you are familiar with. This is a quadratic equation. But this is not a quadratic equation yet, but this can be transformed into a quadratic equation, which is what I do here. So expand this, x minus 1, x minus 6. When you expand this, x times x is x squared, minus 6x minus 1x is minus 7x, minus 1 times minus 6 is plus 6. This is an expansion of just this, all right? And once you expand it, bring the 36 over, so it becomes a minus 36. 6 minus 36 is minus 30. And once you do this, factorize it. So you get an x minus 10 and x plus 3. This is a factorization of what you have here, all right? Now, once you factor it, you have your answers. You have your solutions. Your solution is x equals to 10 and x equals to minus 3. The solutions come from your factors here. All right? Now, for such questions where you are solving, we are solving for x. All right? And we have squared it several times. We've squared it once here. We've squared it another time here. Now, you really have to perform a final check. All right? And you are checking against the original question. So check x equals to 10 and x equals to minus 3 by substituting it into here. So I'm going to first check x equals to 10, and I'm going to check the left side first. This is the left side. So I'm going to take 10 and replace it here. So that's 10 minus 1, and that's 10 minus 6. And 10 minus 1 is square root of 9, and you have square root of 4 here. 3 plus 4 is 5. So the left side gives me 5 when I substitute 10 in it. Now let's see whether the right side, this is now the right side. So this is the left side, this is the right side, okay? Now let's see whether the right side gives me 5 also. So here I take a 10 and put it in. There's a 20 plus 5. 20 plus 5 is a 25. When you square root 25 equals to 5. So the left side and the right side they are both equal. So what does that tell you? That tells you that 10 checks out. 10 is definitely one of your solutions because it checks out. All right, it's verified here. All right, this is a verification step. Now, 10 checks out. Let's check out minus 3. And you will see that when you fill in minus 3, when you put in minus 3, when you substitute minus 3 into your left side, you get square root of minus 4, which doesn't make sense. Square root of minus 9, which doesn't make sense at all. And on the right side, again, you have square root of minus 1, which doesn't make sense. So minus 3 is not one of your solutions. The solution is just x equals to 10. So here, for the questions that involve solve something, all right, and you square it and so on and so forth. We square it twice, we perform the square twice. All right. Now, at the end, you have to do this verification or this checking step. It's absolutely important. All right. Check it with both the possible solutions, and sometimes, like in this case, you will have to eliminate one. All right? Now let's do another one. This is very simple. All right, so you have solve for x again, which means we have to check later. Every time you see solve for x, you really have to check at the end. All right, and before you start solving for this, look at this 24. 24 is a large number and it can be factored. So factored is, what is square root of 24? What is 24? 24 is 4 times 6. So 4 times 6 is really 2 square root 6 here. That, transform it. And why are we transforming it? We're transforming it so that we work with smaller numbers. Why do we want to work with smaller numbers? So that we can decrease the odds of making errors. All right, I love small numbers. So here you have a 4 square root 2x minus 3. Here you have a 2 square root of 6. We have smaller numbers here. Now here, once you see this, you have a 4 here, you have a 2 here, you know that you can divide throughout by 2. So go ahead to divide throughout by 2. You get a 2 square root 2x minus 3, and here you are just left with a 6. How did I get to this step? How is this step arrived at? I arrive at this step by dividing this throughout by 2. And the rest should be kind of standard because you know that you have 2 square root signs. You want to reduce the number of square root signs. Surd questions all involve, how do I get rid of the square root sign? All right, every time you are faced with it, think of how am I going to arrange my equations? What do I have to do so that I can remove my square root signs? Because the square root signs are highly irritating, very difficult to handle. So how are you going to do that? You're going to remove the square root signs by squaring both sides. So that's what you do. You square both sides. When you square both sides, this 2 squared, it becomes a 4. Square root 2x minus 3 loses its square root sign. So square root 6 times square root 6 is merely a 6. And solving this is easy. Multiply this out because you have a 4 times 2x is 8x. 4 times minus 3 is minus 12. That's 6 there. 8x equals to 6 plus 12. Bring that plus 12 over. 8x equals to 6 plus 12 is 18. And x is therefore 18 over 8. All right, which can be simplified to 9 over 4 or 2 1/4. You really can leave it here. But remember, because you are dealing with a solve for x and you have a square here, you have to check. Absolutely necessary that you check. Here you have only one solution to check. Previously, in the previous question, you had to check 10 and then another number. Here you have to check only one number, 9 over 4. So here is a checking step, a verification step. So here what are you checking? You are checking against the original question. So here, just repeat the question here and substitute the 9 over 4 in here. So on the left side, start from the left, substitute x, 9 over 4 for the value of x, and you get 2 times 9 over 4 minus 3. Now that's tough, so multiply that in, you get 9 over 2. 3 is 6 divided by 2. 9 over 2 minus 6 over 2 is 3 over 2. Now 3 over 2, you have a 4 outside there. 4, which has been outside for some time. So bring that in. When you bring that in, it becomes a 16 times 3 over 2. And 16 times 3 over 2 gives you a square root of 24. So your solution of x equals to 9 over 4 checks out. All right, it checks out. So you can say that 9 over 4 is a solution. You have checked it. X equals to 9 over 4 is a solution. Now here again, and what do you do here? Now what you do here is this. You isolate your surd on one side and your non-surd on the other side. So here it looks complicated. It looks complicated because your surd, here your square root of 2x plus 2 is mixed with other things, all right? So, let's clear this thing up. Before we do anything, let's clear this thing up by retaining the surd on one side and all the rest on the other side. And that's what you have. X minus 3 is on this side. You bring the 3 over, you get minus 3. And this minus square root 2x plus 2, bring it over here. So you get a plus square root of 2x plus 2. Now you are ready for business. So here, to get rid of this square root sign, square both sides. That's what you do, square both sides. And once you square both sides, you will see that this square root sign will disappear. And that's what happens here. It disappears. So square root of 2x plus 2 disappears. The square root sign disappears. You just get a 2x plus 2. On the left side, what you do is just to expand this. So x minus 3 squared, you get an x squared minus 6x plus 9. All right, so expand it. And this is your quadratic equation. And right now, I hope you see why I decided to start off with quadratic equation. Here you have your x squared. Minus 6x minus 2x is minus 8x. 9 minus 2 is 7. And once you get that, you know that you can factorize this. And once you have factorized this, you know that you have your solutions. X equals to 7 plus here, from here. And from here, you get x equals to 1. Now again, for a solve for x kind of question, you really have to check these two out. You have to verify it. So the check. One check for 7 and one check for 1. So the 7 one here is a 7. I'm just replacing the 7 here. I put it in red so that you can see very clearly. 7 minus 2 times 7 plus 2. So it's 7 minus 2 times 7 is 14 plus 2 is 16. So it's square root of 16. So that's 7 minus 4 equals to 3. It checks out. It checks out. So 7 is a solution. Now how about 1? Okay, we've got 2. 7, it checks out. What about 1? So you're going to do another check for 1. And it's 1 minus 2 times 1 plus 2. That's 1 minus square root of 4. And that's 1 minus, this is 2. So that equals to minus 1. So that does not check out. All right, it has to end up with a 3. And this is not a 3. So here, your conclusion is that your answer, your solution is only x equals to 7. All right, x equals to 7 is the only solution. X equals to 1 is not a solution. All right, and how did you verify it? That you verified it out of a check right at the end. Remember, every time you are solving something involving surds and you square it, like we did over here, we squared it, you really need to check. You need to verify at the end. All right, I cannot stress this enough. You need to check. Now let's look at this. This looks very blurred because I kind of like snipped it. All right, I used the Windows snip to snip from an exam paper. So this is an exam paper. This is an exam question. All right, and I snipped it out for you. All right, so the solution of the equation is this equation here is a square root 3 minus square root of b. Without using a calculator, no calculator at all, hands off the calculator, find the values of the integers a and b. Find the value of a here and the value of b here, right? And this is what we start off with. This is just from the question. I've not done anything. It's x square root 2 equals to square root of 135 minus x square root 5. This is from the question, all right? And right off the bat, I see that there's an x there, and I immediately what we need to do here is to isolate the x. Because we are solving for x, we want to find out the solution of this equation. We want to solve for x. So to solve for x, we need to isolate x. So that's what I do. I bring the terms with x to one side. So you have x square root 2 plus x square root 5. I brought this over. Why did I bring it over? Because I want to isolate x. Why do I want to isolate x? Because I want to solve for x. All right. So the next thing that is very tempting to do is this 135. The 135 here is a number that is dying to be simplified. It's too big. It's just too big. So 135 is really 9 times 15. Right? It's 9 times 15, and the 9 times 15 is really 3 square root 15. All right. And I've also factored x out here. All right, I've taken the opportunity here also to factor x out. X times square root 2 plus square root 5. So I factored it out. All right. So here, what I end up with is very simple. I end up with what do I end up with? I end up with 3 over 15. All right, 3 square root 15 divided by square root 2 plus square root 5. So I bring this down. Now, this is already my solution, I have solved for x already. All right, it says the solution of the equation, right? I have solved it. This is the solution. But the problem is the question wants the solution in this form. I have the solution, but the solution is not in this form. All right. So here I remember this again: x plus y and x minus y is x squared minus y squared. So that's what I'm going to do to settle this denominator here, to transform it to this form. All right. Note, I have solved it. I've got the value of x. This is the solution. This is a solution, but the solution is not in the form that the question wants. So the next step is just to change, to modify the solution that I have to make it this format. Now, what you note about the format, you note that the format does not have a denominator. It's a square root 3 minus square root b. There is no denominator here. So that means I have to get rid of the denominator. How do I get rid of the denominator? I get rid of it by remembering this. So that's what I do here. All right, it's the same thing, but I'll be multiplying by square root 2 minus square root 5, square root 2 minus square root 5. Why do I do that? I want to do that because I want to get rid of the denominator. Why do I want to get rid of the denominator? I want to do that because the form that the question requests for is without a denominator. There's no denominator here. I have somehow got to kill it. All right. So when I do this, I multiply 3 square root 15 by that. Okay, and that's what I get at the top. At the bottom, I have square root 2 plus square root 5 times square root 2 minus square root 5. So this is a plus b, or x plus y, x minus y. All right, and so this is x squared minus y squared. And when I multiply this, I get 3 square root 15 square root 2, and this is 3 square root 15 square root 5. I'm just multiplying this out. So just go ahead, multiply this out, and multiply the denominator out also. A plus b, a minus b, a squared minus b squared. Once I do that, you will see that magic, because what happens is this becomes a 2, this becomes a 5. Square root 2 times square root 2 is a 2, square root 5 times square root 5 is a 5. Now this 3 here, square root 15 times square root 2 is square root 30. Square root 15 times square root 5 is square root 75. So here 75 again, you want to simplify this because 75 is 25 times 3. All right, 2 minus 5 is a minus 3. So here is all a matter of clearing things up. Okay, so 25 times 3 here, I have a 5. I bring the 25 out, I get a 5 square root 3. And look at this, you have a 3, you have a 3, you have a 3 at the denominator. 3, 3, 3. Surely we can factor this out, and that's what we do over here. So you have a 3, minus 3 here and a minus 3, so you make this division, and that gives you a minus square root 30 plus 5 square root 3. All right, and we overturn it, you have 5 square root 3 minus square root 30. And why do we do that? Because we want it to look like what the question says it should look like. So very simply, A is, if you compare with this, A is a 5 and B is a 30. Very simple. All right. So note this interesting question. This interesting question, we arrive at our answer, but the answer, the solution to this equation didn't fit the format that the question wanted. All right. So what we did was we manipulated till we got the format, and the format is here. I repeated the question so that you can see the format. 5 square root 3 minus square root 30. So A is 5, B is 30. Very simple. Now let's look at this one here. Again, solve. What does this solve mean? It means that what do we have to do? We have to verify that the solution it works. Okay, we have to do a checking step right at the end. Now, so here what we do is this really, looks like a quadratic equation. It looks really like one. So let's transform it into a quadratic equation by using this substitution here. The substitution I'm going to use is u equals to x, u equals to square root of x. So here is really square root of x times square root of x. So here you end up with a u squared. So here plus, this one here is a u, all right, minus 12. And you see that this is a quadratic equation that you can factorize. So this is a u plus 4 and u minus 3. All right, which means that your factors, you have u equals to, your solution is u equals to minus 4 and u equals to 3. But no, your question says solve for x, not solve for u. It says solve for x. So here you really need to bring this back. U is the square root of x, so bring that back and bring that, if the square root of x equals to minus 4, then x has to be 16. If square root of x is 3, then x has to be 9. So now you have two values of x. You have to bring this x and put it here, and bring it and put it here to check. You're going to do two checks, one for x equals to 16, one for x equals to 9. So let's do the one for x equals to 16. So to do the check for x equals to 16, just bring the 16 and put it in here, bring the 16 and put it in here, and you will see that 16 remains, square root of 16 is 4, 16 plus 4 is 20, 20 minus 12 is not 0, 20 minus 12 is 8. So 16 is not a solution. Out. 16 is completely out. You've knocked it out. It's not a solution. Now do the check for 9. 9 plus square root 9. I'm just replacing 9 here. All right. So that equals to 9 plus 3 minus 12, and that is 0. And what does that tell you? That tells you that 16 is not a solution, but x equals to 9 is a solution. So x equals to 9 is your only solution. That's your only solution there. All right. 16. X equals to 16. Trash it, toss it out. It's not a solution. Okay, again, solve for x. Okay, and you see the equation here. All right, and very simple. Again, you have square root signs there that you want to get rid of. Third questions, remember, square root signs, you want to get rid of the square root signs. And one of the most popular way of getting rid of square root signs is really by squaring it. If you square a square root, you get rid of it. Right? So you square both sides. You remember that you have to square both sides. You cannot square one side without squaring the other side. Both sides have to be squared. So when you square 3, you get a 9. When you square this square root x plus 10, you just get rid of the square root sign. When you square root 5, you get a 25. Square root this, you get x minus 6. And the rest is simple. You just expand it, 9x plus 90, 25x minus 150. And solve for x, 25x minus 9x, 150, when you bring this over, the minus 150 becomes 150 plus 90. So ultimately you get 16x, 25x minus 9x is 16x. 16x equals to 150 plus 90, which is 240. So your x equals to 15, which you have to test. Remember, you are solving for it. You have a square here. You have to test this 15. So you test the 15. You check it out by putting it into this equation. So I repeated the equation here. So you're going to test it out. This is the left side. Always test the left side and then the right side. So the left side you bring the 15 in here, which is 3 times square root of 25. Square root of 25 is 5. So 3 times 5 is 15. This is your left side. Now let's do the right side. So right side is 5. This is 15 minus 6. 15 minus 6 is a 9. So square root of 9, you get a 3. So 5 times 3, you get a 15. Left side over here, right side over here, they are both equal. And so your answer checks out. X equals to 15 is the solution. All right? You must do a final check. In your final check, you may encounter that if you have two solutions, perhaps one of them you've got to toss out. All right? Sometimes, in fact, a lot of times, this will be the case. Now, let's do another solve for x question. All right? This is very, very easy also. Again, you have two square root signs. You have to get rid of it. All right? So how do you get rid of it? You square both sides. Square both sides. What you get over here is a 25. What you get over here is an x plus 1 plus x minus 4 plus 2 square root of x plus 1 square root of x minus 4. So from two square root signs, you manage to reduce it to just 1. Again, I stress that this looks like it's two square root signs. It's actually just 1. All right? So, here, you have 2x, x plus x is 2x. You bring it over, it's minus 2x. 1 minus 4 is minus 3. When you bring it over, it's plus 3. So here is the process of simplification. Right? 25 plus 3 is 28 minus 2x. Divide throughout by 2. Divide throughout by 2 so that you end up with just this square roots over here and 14. 28 divided by 2 is 14. Minus 2x divided by 2 is a minus x. Alright? And you want to get rid of this, so you square yet again. You squared once here already, you square a second time. Alright? When you square a second time, you will see that your square root signs disappear. Alright? And when you square this, it's 196. 14 times 14 is 196. X times x is x squared. 2 times 14 times minus x is minus 28x. Okay, so what you do next is just to expand this out. Alright, expand this out. Okay, this is the expansion of this. X times x is x squared. Minus 4x plus x is minus 3x. 1 plus times minus 4 is minus 4. So once you've expanded this, you're back to your equation solving. X squared and x squared, you have x squared on both sides, they cancel out. It's not even a quadratic equation, it's a linear equation, super simple. Minus 28x, when you bring it over, it's a 28x minus 3x. 196, you bring that over, it's a plus 4. Minus 4 becomes a plus 4. So you get a 25x equals to 200. 28 minus 3 is 25. 196 plus 4 is 200. So your x is simply an 8. Very simple. Alright, x equals to 200 divided by 25. 200 divided by 25 is 8. Alright, now you have to do the check. It's a solve for x equation. You have to check. Alright, you have to do the final test and you check it against this left side first. So you bring the x 8 and put it in 8, x equals to 8 and substitute it into here. 8 plus 1 is 9, 8 minus 4 is 4. So square root of 9 is 3, square root of 4 is 2, 3 plus 2 is 5, which is what you wanted to get. Alright, so x checks out, x equals to, your x equals to 8 checks out, so x equals to 8 is the solution. Alright, so remember, you really have to check out your solutions. Alright, now another one, okay, again, you'll be able to tell me now. Alright, square both sides. Why are we squaring both sides? Because we want to reduce the number of surds. The number of square root signs, we want to reduce it from 3. Is a 3 here, we want to reduce it, and we want to reduce it to none. Alright, the ultimate number of square root signs should be none. So when you square both sides, you will see that this side, the square root sign disappears. Alright, here you get x plus 5 plus x minus 3 plus 2 times square root of x plus 5, x minus 3. Now do the simplification here. You have a 2x plus 2. So when you bring that over, you will see that x minus 2x is minus x. 12 minus 2. How did I get a minus 2? Because you have a plus 2 here, you bring over that side, you get a minus 2 is plus 10. And how do you get rid of these square root signs? You square again. So I hope the procedure is becoming quite standard to you. Right? The procedure is very standard. For surds, it's really quite standard. And what do you do in surds? You get rid of the square root signs. Okay? So here, when you square root this, you get a 2 squared is a 4, and you get an x plus 5 and x minus 3 here. When you square that, you get an x squared plus 100 minus 20x. The square this. Alright? And the rest is all clearing up, all clearing up. So you multiply this out, you get an x squared plus 2x minus 15. Alright, and you multiply 4 into the brackets, you get 4x squared, 8x, and minus 60. And from here, you form your quadratic equation. 4x squared minus x squared is 3x squared. 8x minus 20x is plus 28x. You bring this over, is plus 20x. So 8x plus 20x is 28x. Minus 60, when you bring that over, is minus 160. Alright? Factorize it. Get your solutions. From here, you get x equals to minus 40 over 3. From here, you get x equals to 4. These are your solutions, which you have to test. Remember, you have to test. Okay? So when you test x equals to 4, it checks out. X equals to 4 checks out. When you bring 4 in here, you get a square root of 9, you get a square root of plus square root of 1, 3 plus 1 is 4. When you do it, this is for the left side, and when you do the same thing for your right side, you put 4 in, 4 plus 12 is square root of 16, square root of 16 equals to 4. So 4 on the left, 4 on the right. 4 is definitely, x equals to 4 is one of your solutions. Now you have another solution, x equals to minus 40 over 3. When you bring that in, you see that it doesn't make sense. All right, because minus 40 over 3 plus 5 is a negative number. You cannot square root a negative number. Again, you are trying to square root a negative number here. It doesn't check out. So your only solution is x equals to 4. X equals to 4 is your only solution. Okay? Now, simple one, okay? My time is running out, okay? But I want to go through, many questions. So solve for x. This is your equation. And this should be familiar to you. Multiply both sides. What's the problem here is the denominator. You have a denominator of square root x times x minus the square root of x minus 1. So bring the, get rid of the denominator by multiplying both sides by square root of x minus 1, and that's what you get. When you multiply the left side by square root of x minus 1, you get rid of the denominator. When you multiply the right side by square root of x, you get a square root of x minus 1 squared. Okay? Once you have done that, you have, what's the progress you've made? The progress that you've made here is that you've gotten rid of your denominator. Your denominator disappears. And the denominator gives you a big headache here. It's what's giving you a big headache is the denominator. And here, you have managed to get rid of it. All right. After that, multiply this out. Square root of x times square root of x is x. 2 times this is minus 2 square root of x. Minus 1 squared is plus 1. And once you have this again, all right, you have this, bring it over. You get this. You get 3 square root x equals to x. 2 square root x plus square root x is 3 square root x. And don't do any cancellation. Bring this over. So you have 3 square root x minus x equals to 0. And once you have done that, factor it. So if you have factored this, you see that this is, bring square root of x out, you get a 3 minus square root of x. All right, and this gives you 2 solutions. This is square root of x is 0 and square root of x equals to 3. This comes from here. This comes from there. All right, square root of x equals to 3. Now you've got 2 solutions. X equals to 0, x equals to 9, and you've got to test for both solutions. So let's test out both solutions. So when you test out 0, let's test out 0 first. When you test out 0, your left looks like that. 1 plus square root 0, square root 0 minus 1. So on the top, on the numerator, you get a 1. On the denominator, you get a minus 1. And so 1 divided by minus 1 is a minus 1. This is your left side. On your right side, you get a 0. Square root of 0 minus 1, you get a minus 1. So 0 is definitely a solution. 0 checks out. 0 is a solution. Good. Okay? Now let's do 9. When you substitute 9 on the left side, you get 1 plus square root 9. Square root 9 minus 1, you get a 4 on the top over 2, you get a 2. All right? Now, when you substitute 9 on the right, you also get a 2. Square root 9 is 3 minus 1 is 3 minus 1 is a 2. So x equals to 0 and x equals to 9 are both solutions. Amazing. They are both solutions. All right, so you cannot reject 0 because it works out. You cannot reject 9 because it works out also. So 0 and 9 are both solutions. All right, none are rejected. None of them are rejected. Okay. I tell you what I'm going to do is I'm going to end with this. Okay, I've got one very good question at the end, but let me end with this. Okay, so show that 2 minus 1 over 2 plus square root 3 equals to that. So you got to show that. Okay, I want to show you this question because it's not a simplified question. It's not a solve for x question. All right, it's show. So here you begin with the more complicated side, and the more complicated side is 2 minus 1 over 2 plus square root 3. All right, and once you see this kind of thing, 2 minus 1 over something, bring it over the denominator. So once when you bring it over the denominator, you have 2 times 2 plus square root 3 minus 1. And when you multiply that out, you get a 2 times 2 is 4, 2 times square root 3 is 2 square root 3 minus 1. All right, and of course, simplify that. When you simplify that, it becomes this. And you have shown that this equals to this. That's what you have done. You have shown that this equals to this, but you want to show that it's equal to square root 3. You don't want to show that it's equal to this, right? So you have got to proceed some more, and remember this, x plus y times x minus y is x squared minus y squared. So what you do is you begin from here now. You begin from here. You've proven that this equals to this, so you begin from here, and you multiply by 2 minus square root 3 on the top and 2 minus square root 3 at the bottom. Remember, plus you've got to change it to minus. And when you change it to minus, you have 2 squared minus square root 3 squared, and that's what you have. On the top, you have 3 times 2 is 6. 3 times square root 3 is 3 times minus square root 3 is minus 3 square root 3. 2 square root 3 times 2 is 4 square root 3, and 2 square root 3 times square root 3 is just that. And all you have to do is a process of simplification from here. 6 comes from here, minus 3 square root 3 plus 4 square root 3 just gives you a square root 3 here. This is a minus 6 here, it comes from here. So 2 times 3 is a 6. So you will see nicely that things are coming into place, because at the bottom you get a 1, at the top 6 minus 6 gives you nothing, leaves you just a square root 3, and you get your square root 3 here. Wonderful. Absolutely, absolutely wonderful. All right, so you have proven that this equals to that, and that you went further to prove that it equals to square root 3. So you have shown that this whole thing equals to square root 3. Okay. Okay. I have actually one last question. All right, which I think I will just go through. All right, although it's over an hour and all that, I'll just go through. All right, because this is another exam question from a Singapore school. I cut and I snipped it. Now this diagram below shows a cuboid. Cube, all the sides are the same. Cuboid, all the sides are not the same. All right, so there's a possibility that the sides are not the same. Now the height AB is here. Height AB is square root 5 plus 4. This is your height. All right, and given that the length of the diagonal AC, this one going across the cuboid here, this is a cuboid, the line going across the cuboid is 41 square root 5 divided by 3 square root 5 plus 2. This is the length. What is this? This is the length of this, this line here. All right. Now, there are two parts here. Find an expression for BC squared. You want to find an expression for BC squared in the form of this, where C and D are integers. And the last one is find the area of the square base. Hey, you are told that the base is square. All right, so find the area of the square base. Now, the problem with this question is this. Most students rush in to solve this question. Okay, that's the last thing you should do. Don't rush in to solve this question. Now, look at this question and you will see that this is a problem here. 41 square root 5 divided by 3 square root 5 plus 2. This is a problem, and this thing, I encourage you to, before trying to solve this question, have simplify this first. Because once you simplify this, the rest of the parts become very simple. If you don't simplify this, you will see that going straight to A and going straight to B will be a disaster. Will be an absolute disaster. So very important, very, very important. What you do, very important to simplify this first. So first thing I'm going to do is not going to do A. I'm going to ignore A. I'm going to ignore B. I'm going to do one whole slide of just simplifying this. So to simplify this, you remember this, and you know that just multiply by, 3 square root 5 minus 2. It's a plus 2 here, so multiply by minus 2, 3 square root 5 minus 2, top and bottom. All right, and why do you do that? You do that because you want to turn the bottom into a number, all right, from a surd to be a number. So here you get 3 square root 5 squared minus 2 squared. And on the top, 41 times 3 is 123. Square root 5 times square root 5 is there. 41 times 2 is 82 square root 5. So here, all you need to do is to simplify this. 123, this becomes 5. 82 square root 5. This is 9 times 5. 9 times 5 is 45. This is a 4. So when you simplify, you see that 45 minus 4 is 41. This is 615. Take a calculator out, you see that this is a 615. And when you divide 615 by 41, you get 15. 82 divided by 41, you get a 2. So 15 minus 2 square root 5 centimeters. How do I know this is centimeters? Because everything else is in cm. For this sort of a questions, you've got to be alert. This is a cm, this is a cm. When you work out, when you simplify this is already a cm. When you simplify it, you've got to put a cm there. All right? Now with this, we are ready to handle part A. We are ready to tackle part A. What's part A? Part A is find an expression for BC squared. This is your BC. And this is find an expression for BC squared. And I find an expression for BC squared by noting that ABC, the angle ABC, the angle here is 90 degrees. This angle here is 90 degrees. All right, so you have a 90-degree angle here. So I can, because it's a 90-degree angle, I can use Pythagoras Theorem. And this is Pythagoras Theorem. AC squared equals to AB squared plus BC squared. Right, this is Pythagoras Theorem. And once I have done that, I can replace what I found here. Remember, I found this here. I can replace in here. Imagine if I didn't do the simplification, the AC, I have to take from here, 41 square root 5 divided by 3 square root 5 plus 2. I've got to put it over here. It will be a disaster. So I put the simplified form here. So this earlier slide of simplification is important. If I didn't simplify here, I would not be able to proceed. So put the simplified form here. The AB squared is here, AB. So it's 5 square root 5 plus 4. Put it over here. And what I'm trying to find is the BC squared, an expression for BC squared. After this, it's very simple because I'm just simplifying this. 15 squared is 225. And here you have 2 squared is 4. 4 times 5 is 20. So 2 times 15 times 2 is minus 60 square root 5. Here I have expanded it 5. It comes from here. 16 comes from 4 squared is 16. 2 times 4 is 8 square root 5 plus BC squared. So after this is just a process of simplification. 225 plus 20 is 245. 5 plus 16 is 21. Simplify this further. 245 minus 21 is 224. Minus 60 minus 8 is minus 68 equals to BC squared. And I have found an expression for BC squared. BC squared is 224 minus 68 square root 5. That is BC squared. All right. Now, after solving A, I've already found the expression. The expression is 224 minus 68 square root 5. Now, after that, all right, so, expression in where C and D are integers. So C is 224, D is minus 68. So look at this and take your C here, 224, D is minus 68. Now, the next one is hence. That means from what I have found here, find the area of the square base. Now, to find the area of the square base, I'm told it's square. So square means the length and the width are the same. So x and x. I'm putting x and x here because I've been told that this is the base. This is the base. I'm being told here that the base is square. So x times x. So here, the area is x times x is x squared. Because I put x times x, x squared. But from Pythagoras Theorem, I know that x squared plus x squared equals to what I have found here. I have found an expression for BC squared. So the expression for BC squared is 224 minus 68 square root 5. So here I found that x squared plus x squared from Pythagoras Theorem equals to bc squared, what I have found in part A. Alright, hence means I have to use the results from part A. I cannot ignore the results from part A. I have to use it. Alright, whatever it is, I have to use that results. So here, I have shown that x squared plus x squared by Pythagoras Theorem equals to bc squared. And that is 2x squared equals to that. Alright, x squared plus x squared is 2x squared. X squared is just 224 minus 68 divided by 2. Alright, and that's what I get for x squared. So the area equals to 112 minus 34 square root 5, and you have to put this cm squared here. Remember, all these things equals to marks. If you forgot to put this in, if you omitted cm squared, marks may be deducted. So remember, put down the cm squared here. Alright, so I have done. This question is an important one. If you can redo this, this question is quite long because it says this, it gives you the length of AC in this horrible format. And the secret to this is not rushing into the question, but before you rush into A and B, simplify this. If not, you will, so this is the simplified form. If not, you will have to use this terrible form over here, which is going to be absolutely terrible. Alright, so use the simplified form here and proceed to find an expression for BC squared, and then after that find an expression and find out your area from whatever you have found out. Alright, and so this is all for today. Thank you for watching. Next week I will have another one for logarithms. So last week was indices, this week is surds, next week I will do something for logarithms. If you have friends, ask them to join in. Alright, I'm enjoying myself, so ask them to join in. I hope they will learn something new. I hope you have learned something new. So I hope to see you again next week at the same time. Alright, so again, if you have found it useful, please come back next week. Alright, please come back next week. Alright, so my YouTube channel is here, my email is here. If you have any questions, you are free. Please just contact me at this particular email address. Alright, so thank you for watching. See you next week. Bye-bye.